Good morning, my dear students. I, Samir Kumar, welcome you all in my 15th video lesson of Physical Sciences. Okay, students, so now let's begin our class without any further delays. So, students, have you seen this type of things? Yes, students, sometimes when you come to the school, you might have seen this type of signboards present on the road, isn't it? Yes. So, students, what does this sign indicates? Do you know what does the sign indicates? Yes. Right. So this sign is of a speed limit, isn't it? This sign indicates a speed limit. Right. So students, what is speed? We learned about speed in our previous classes now. So we define speed as the rate of change of distance, right? So speed is defined as f equals to d by t. Right, students? This is what we have studied. Okay. Now, students, when you might be driving your cycle, then you might have a speedometer in your cycle, or you might have seen that your parents drive a car, right? So you might have seen this type of instrumentation cluster, isn't it? Have you seen this type of meter in your car? Yes, right. So, students, what does this indicate? Right. So, this is a speedometer. Okay, students, this is a right, this is a speedometer, and this speedometer is used to tell us about the speed, right? So now, can you think how we can describe the non-uniform speed? Because I don't think so that when you are coming to the school, then you are coming at only at say 10 kilometers per hour. Sometimes you might be traveling at 50 kilometers per hour, but sometimes you might be traveling at 5 kilometers per hour or even 1 kilometer per hour. So we can say that the speed is not uniform. Okay, students? So how we describe the uniform speed? The question is this. Okay, students, I'm giving you 10 seconds to think about this question. Okay, the question is how we can describe the non-uniform speed. Okay, students, right? So let's see how we describe the non-uniform speed. So students, we describe the non-uniform speed by taking the average speed. Okay, students? Right. So measuring the rate of the motion of an object is to find out the distance traveled by the object in unit time. When we are measuring the rate of the motion of the object, then we are trying to find the distance traveled by that object in a unit time. Say that if we can try to find out the speed, like say S equals to d by t, right? So we know that speed equals to the rate of change of motion of the object, isn't it? Right? So we say that by measuring the rate of motion of an object, we find the distance traveled by that object, okay? So this quantity is referred to as the speed. And what is the SI unit of speed? The SI unit of speed is meter. Okay, students? Meter will be for distance, and for time we use seconds, so the SI unit of speed will be meter per second. Understood, students? Right. So whenever we are trying to find the rate of motion of an object, what we do, we divide distance by the time taken. Understood, students? So this quantity is referred to as the speed, and this speed is having what? This speed is having a SI unit, which is what? Which is meter per second. Okay, students, understood this point? Right. So now let's proceed ahead. So students, the average speed of an object cannot be constant. Okay, should not means it can be constant, but it need not be constant. Okay. So suppose that if I want to come from my home to the school and say it is 5 kilometers. Okay. So I can take my journey as I can start from point A, right, and reach to the point B in say 1 hour. So in 1 hour, I am traveling 5 kilometers, right? So I can travel at a speed of 5 kilometers per hour. Then also I will reach from A to B. But it is not the situation, because what will happen, there will be traffic jams, there will be some other type of situation. So my journey will be like this. I will start from the home, right? Then after that, I will reach some distance. There I might be traveling at 10 kilometers per hour, right? After that, there might be some traffic jams. There I may be traveling at 1 kilometer per hour, and rest of the journey I will be calculating, right? So the average, the speed of the object throughout the journey need not be constant. Okay, so in most cases the objects will be in non-uniform motion. Understood, students? Therefore, to describe the rate of motion of such objects, we use the term what? We use the term of average speed, right? We use the term average speed. So what is the average speed, students? So average speed, students, we get by dividing the total distance taken traveled by the total time taken. Okay, students? So average speed equals to total distance divided by total time. Understood, students? So this is the formula for the average speed. So now let's proceed ahead. So this is the formula, students. Speed equals to distance by time, right? So these are different types of units that you will find for speed. Like you can find speed in terms of miles per hour, right? It can be denoted as mph. You can find the speed as kilometer per hour or kmph. Okay, students. You might find the speed as meter per second, or it can be written as like this, right? So these are different units of speed. Okay, miles per hour, kilometers per hour, meter per second. But this is the SI unit of speed. The SI unit of speed is what? It is meter per second. Understood, students? Right. So now let's proceed ahead. So students, there is a quiz for you, and the quiz is that an object travels 16 meter in 4 seconds, right? An object is traveling 16 meters in 4 seconds and another 16 meters in 2 seconds. Then what will be the average speed of the object? Okay, students, just try to calculate this. I am giving you 10 seconds before we can solve it together. Okay, students? Right. Yes. Now let's see how this question can be solved. So let me illustrate this question once more. So it is said that there is an object. Okay. Let's say there is an object and that object is traveling from point A to point B and from point B to point C, right? So the distance between point A and point B is 16 kilometers. The distance between point B and point C is also 16 kilometers, right? So the time taken to travel from A to B is 4 seconds. The time taken to travel between B and C is 2 seconds, right? So this is the question, and we need to find what is the average speed. So we know that the average speed equals to what? Average speed equals to total distance by total time. So the total distance is what? 16 plus 16, that is 32 kilometers, or 32, sorry, it is meters, right? It's 16 meters, right? So 16 meters, it travels in 4 seconds, and it travels another 16 meter in 2 seconds, right? So it will be 32 meters divided by 6 seconds. This will be equal to what? Yes, students, it will be equal to 5.53 meter per second. Understood, students? Right? Okay, so now let's quickly see one more time how this question is being solved here. So first of all, we write the formula for average speed. The average speed equals to what? It equals to total distance traveled by total time taken. So the total distance is 16 kilometer plus 16 meter plus 16 meter, right? It will be equal to 32 meter, and the total time is 4 plus 2, this equals to 6 seconds. So the final answer will be 5.33 meter per second. Understood, students? Right. So now let's proceed ahead. So students, there is a picture shown to you. Can you see some things in this picture? Okay. So now suppose that you are in this car. Okay, you are in this car, and this car is traveling at a speed of 2 km/h, right? So where you will reach first? You will reach school first, or will you reach home first? Yes, students? Right. So we can say that we will reach that place first which is having less distance, right? But students, there is one more term here, right? You can see the school is in this direction, but the home is in this direction. Okay, students? So now when we add the distance component with the direction component, then what we get? We get the velocity. Okay, students? Now let's see at this picture. You can see the speed of car in this case is also 25 meter per second, right? The speed of car in this case is also 25 meter per second, and in this case is also 25 meter per second. Say that we are taking the positive in this direction, right? We are taking positive sign in this direction, so there will be negative sign in this direction, right? In opposite direction. So the velocity of this car will be what? The velocity of this car will be minus 25 meter per second, right? And the velocity of this car will be plus 25 meter per second, right? So students, the rate of motion of an object can be comprehensively specified if we describe what? If we describe the direction of the motion along with its speed, right? Whenever we are describing the direction of the motion along with its speed, then only we can describe the rate of the motion more easily, right? Or more knowledgeably. Okay, students? So the quantity that specifies both the aspect is called the velocity. And what are both the aspects? Both the aspects are, yes, students, the rate of motion, or we can say speed, and the direction. So when we add the direction component to the speed, it becomes the velocity. Okay. So when an object is moving along a straight line at a variable speed, we can express the magnitude of its rate of motion in terms of its average velocity. Okay, students? Suppose that there is a body and it is moving along a straight line, right? It is moving along a straight line. So its motion can be described as in the terms of average velocity, right? And how do we calculate average velocity, students? We calculate average velocity in the same way as we calculate the average speed, right? So what will be the formula? It will be total displacement. It will be total displacement by total time. Okay, students. So the formula for the average average velocity will be total displacement divided by total time. Understood, students? Right. So now let's proceed ahead. So students, we have saw this picture in our previous class also, and I have told you the difference between the distance and the displacement. So now who will tell me what is distance and what is displacement? Yes? Okay. So now let's see what is distance and what is displacement. So students, let's take the example that we took in our previous class also. Let's say there is a person A standing here and he wants to reach his friend B who is standing here, right? So he might take a long path, right? He might take a long path in this direction and come to his friend B, right? So that will be what? That will be the distance. Okay, students? But now when we are calculating the displacement will be the shortest possible path between these two friends or between these 2 points, right? So the displacement will be a direct connection or a direct straight line from A to B, right? So this will describe the displacement. Okay, students? Right. So now let's see what is the difference between the speed and the velocity. Okay, right. So students, we define speed as the rate of change of distance. Okay, students, how do we define speed? We define speed as rate of change of distance. Okay, students. And how we define velocity? We define velocity as the rate of change of displacement. Understood, students? So in the case of speed, it is the distance, and in the case of the velocity, it is the rate of change of the displacement, right? Speed is a scalar quantity and velocity is a vector quantity. Okay, students? Right. So speed of a body can be never be negative or zero. Okay, students? The speed of the body can never be negative or zero, or we can say that whenever something is moving, it will be having some sort of speed. Okay, understood? So if the speed is zero, that means that the body is not moving at all. Okay, students? But since the velocity depends upon the displacement, we know that the velocity can be negative, positive, or zero. Okay, students? So the velocity can be negative, positive, or even zero, right? So what is speed? What is the relation between the speed and the velocity? Yes. So speed is the velocity without the direction component. We can say any velocity. If we not justify the direction, then it is the speed, right? So what is velocity? Velocity is directed speed, right? Velocity for the when we are describing velocity, we need to describe what? We need to describe the direction also. Understood, students? Right. So we can say that the speed may or may not be equal to the velocity. Understood, students? The speed may or may not be equal to the velocity. Why? Because it is the actual path covered, right? So it is depending upon the distance, and distance is the actual path covered. So it might be or might be not equal to the velocity. Okay, students. So since the velocity depends upon the displacement, a body might have the different velocity at the same speed. Understood, students? Right. So now, students, there is a quiz for you. So you need to differentiate between the distance and displacement. Okay, you can just give any 3 points. Okay, so the first point can be speed is a scalar quantity and velocity is a vector quantity. Understood, students? Right. So we can say speed as velocity without the direction, and velocity is the directed speed. Understood, students? Yes. So the speed of the body depends upon the distance covered by the body, but the velocity of the body depends upon the displacement that has happened in that body. Okay, students? Right. So now let's proceed ahead. So students, while you are in a car, you might have saw this type of pedals, isn't it? So one pedal is for accelerator, right? One pedal is for accelerator. I'll write it here. This is for accelerator. This is for brake, and this is for clutch, right? So this is ABC of the car, right, students? So what happens when you press the accelerator in the car? Yes, students? Right. So when we press the accelerator of the car starts to accelerate or move faster. Okay. So students, you know why it is named as accelerator? Why is this pedal known as accelerator? What can be the reason? Okay. Now let's see. I'll tell you the reason. Let's see this picture, okay, students? Yes. So, students, you can see this person is jogging 5 meters in 1 second. Okay, so this is his velocity, right? 5 meter in 1 second. Okay, students, right? And this person is traveling is sprinting at 10 meters in 1 second. So it is her velocity, right? So now when we describe the rate of change of velocity, okay, students. Now suppose that we want to describe the rate of change of velocity. How we will describe the rate of change of velocity, students? Yes, it will be velocity by time. So we know that velocity equals to what? Velocity is distance, displacement or distance. It is the displacement by time, right? So write it displacement by time and you multiply it by time because of this time, right? So it will be d by t squared, right? So this is the formula for the acceleration, or we can say rate of change of velocity. Understood, students? Now let's see what is the rate of change of velocity. So students, it is defined by the term called as the acceleration. Okay, so this is defined by the term acceleration. So acceleration is the measure of the change of the velocity per unit time. Okay, students. So what is acceleration? Acceleration is the measure of the change of velocity per unit time, right? So if the velocity, now suppose that if the velocity of an object is u and it changes to v, then what will be the final acceleration here, students? It will be v, that is the final value of acceleration minus the initial value of acceleration divided by the time. So that will be equal to the acceleration. Okay, students, right? So now let's proceed. So now students, let's learn about the uniform and the non-uniform acceleration. Okay. So students, if the acceleration is constant, right? So if there is a constant acceleration, we say that it is a uniform acceleration, right? So acceleration is constant in the case of uniform acceleration, but it is not constant in the case of non-uniform acceleration, right? So in the case of uniform acceleration, what happens, student? The velocity increases equally in equal intervals of time. Okay. So suppose that if the velocity is increasing at the rate of 2 meter per second square, so then the velocity will be increasing at 2 meter per second square in every section. Okay. But in the non-uniformly accelerated motion, the velocity does not equally increase at all the intervals of the time, right? So sometimes it might increase at 4 meter per second square, or some other times it might increase at 10 meter per second square, right? So this is the non-uniform acceleration. Okay, students. So let's see the example of uniform acceleration. Suppose that a ball is dropped from a height. Okay, when a ball is dropped from the height, then what is happening? As acceleration due to gravity is working on it, right? So it is the case of uniform acceleration. But suppose that if a car is traveling 2 kilometers in first hour and 2.5 kilometers in the second hour, so this is the example of non-uniform acceleration. Okay, students? Right. So now let's go to the quiz section. Yes. So differentiate between the uniform and non-uniformly accelerated motion. Yes, students? Right. So in the uniformly accelerated motion, we say that the acceleration is uniform, means there is equal acceleration in equal interval of time. But in the case of non-uniformly accelerated motion, we say that the body experiences unequal acceleration in equal interval of time. Okay, students? Right. So now let's proceed ahead. So students, in our today's class, we have learned about measuring the rate of motion. Yes. So let's quickly revise the class by answering a few questions. So how can we differentiate between the uniformly and non-uniformly accelerated motion, students? Yes. In the case of uniformly accelerated motion, there will be equal acceleration, equal change in acceleration in equal interval of time, right? But in the case of non-uniformly accelerated motion, there will be unequal acceleration in equal intervals of time. Okay. So how do we define velocity, students? Velocity is defined as the rate of change of displacement, right? So we define velocity as rate of change of displacement. Okay. So how do we define average velocity? Yes, we define average velocity as the total displacement by total time. Okay. So average velocity is defined as the sum product or sum total of all the displacement when it is divided by the total time taken to do all those displacement. It is called as the average velocity. So students, when we compare speed and the velocity, we find that the speed is a scalar quantity, whereas velocity is a vector quantity. Speed does not require any direction to be justified, but velocity needs a direction, right? So how do we differentiate between distance and displacement, students? Yes. So the distance is the all the path that has been taken. It is constitutes the distance. Okay. But the displacement is nothing but it is just the shortest possible path between the 2 points. Yes. So students, how can we justify that a body that is falling freely is having a uniformly accelerated motion? Yes, students. Right. So the acceleration acting on the body is the same, that is acceleration due to gravity or g. So therefore, we say that the acceleration of a freely falling body is uniformly accelerated motion. So now students, let's look at your homework. So this is your homework. What you need to do is measure the time it takes you to walk from your house to your bus stop or to the school. So if you consider that your average walking speed is 4 kilometers per hour, estimate the distance of the bus stop or the school from your house. Okay students, so this is a very simple question that you need to do in your homework copy. Okay students, right. So I thank you all for attending my today's class. All the best. I hope you will have a good day. Thank you, students.